Today I will show you how to train your own stable diffusion models with Colossal-AI. Let's start. So firstly, we need to get clone the repo from the GitHub. You just run git clone. Then we change out your directory to the stable diffusion direction. Okay, now let's start the first step. We need to create a new conda environment from our environment.yaml. You just run the command, and then you need to activate your conda environment. Okay, now you have finished install the conda environment, and let's go to step 2. You need to install the PyTorch Lightning. The Colossal Diffusion is trained with the PyTorch Lightning, deep learning framework extension for the PyTorch. And we also need to get clones from the GitHub, the Lightning repo, and then install it. Let me show you. You need to pip install some requirements, and then run python setup.py install. Let's wait for a minute. Okay, now we go to the last step. You need to install the Colossal-AI. Yeah, to install the Colossal-AI, you need to install CUDA. And in my machine, I need to load my CUDA module by the module loader. And I choose the CUDA version. And load my CUDA. Then, you just need to run pip install. And the Colossal-AI will be installed to your conda environment. Yeah, it may take some time, and I speed up. Okay, now after finish above, you can start your training task. Let's turn back to the Colossal Diffusion directory. We have offered a shell script to train your own stable diffusion models, and it is very convenient to use. And also, we offered a dataset from the Hugging Face. Yeah, it is about the gene impact. And the label is generated by the blip model, yeah, with the image, and you can train your own stable diffusion fine-tuned model by our dataset, and it is very easy to use because it will be downloaded from the Hugging Face datasets. And also there is also a training config YAML if you want to train your own model. Yeah, let me change the YAML in my shell scripts. And here in the YAML, you can configure your training setting about how many devices, how many Gemini devices, and whether use FP16 and the chunk size for the Gemini. Now let's start training. Okay, it is start training, and the first time you train the model, the shell script will download some model weights from the Hugging Face, and now it is starting the distributed training on every GPU. Okay, now it is start training, and to speed up, I set the epochs to the 2, and it will be finished in a small time. Okay, now it finishes the epoch 0 and to the epoch 1. And you can see some information on your terminal about the loss, learning rate, and other useful information. And you can also add some log information in your model code. It is very convenient. Okay, it's finished the training. Now let's take a look at your checkpoint and the training config. There will be the declaration of your log dictionary, and you will find your checkpoint. Let me change the dictionary. Okay, here is your training result, and let's change the dictionary. You will find the checkpoints directory, and last checkpoint for the pair torch in this directory. And in the config directory, you will get your training config, both about the model information and the training setting. And here are some log informations. Okay, about show how to train the stable diffusion. Now I will show you how to inference with the diffusion models. We also offer a shell scripts, and it is very convenient to inference your checkpoint. And we also support int 8 inference. It will be very faster than the normal version. And here are some arguments for the inference setting. For example, about some width or height of the image size. And here is the train script. You should configure it with your own YAML config and checkpoint. Now, let's run the shell script for the inference. Okay, it starts running, and it may take some time to load the model. Now it starts inference, and you will get your result on the output directory. Let me show you this result. And here is the result picture with the promote of a woman with a sword, and it may very fantastic. Okay, now I showed you how to create a content environment and retraining our stable diffusion and how to inference it. For more detailed information, you can refer to our doc. It is very convenient. Thank you.